Hello everyone, it's Indradeep Kumar, Assistant Professor IARE, Hyderabad. We are seeing numericals related to the Goodman relation. Okay, now in this video we will see numericals on stress concentration factor. Means if stress concentration factor is given, then how we will use that in the numerical. Okay, so see the question first. A bar of circular cross section is subjected to alternating tensile forces varying from a minimum of 200 kilonewton to a maximum of 500 kilonewton. So just see again, range is given. Minimum is this one and maximum is this one. In previous video also we had seen in terms of range they given that maximum minimum. From there we found the sigma mean and sigma amplitude. So again here, it is to be manufactured of a material with an ultimate tensile strength of 900 megapascal. So here what is given? Sigma ut is given as 900 megapascal and an endurance limit of 700 megapascal. So in previous question what was given? Right, they were given as factor of safety like 0.55 of sigma ut. Instead of that they given directly here the value. So no need to calculate sigma e and sigma yt. We have directly sigma e and sigma yt. Now determine the diameter of bar using safety factor of 3.5 related to ultimate tensile strength. So for ultimate tensile strength, you have to take 3.5 and ultimate tensile strength and 4 related to endurance limit. So for in case of endurance limit, the factor of safety will be 4 and a stress concentration factor of 1.65 for fatigue load. So for fatigue load, concentration factors, now just see here, this is given. In previous question, we haven't seen this one. Right, so now the stress concentration factor is there. Use Goodman straight line as basis for design. So means again we have to use the Goodman relation to solve this question, and then we will use these given values to solve. So just say first, given W mean 200, W max 500 kilonewton, sigma u is given as 900 megapascal. Right, now just convert this into, because now we have to find what? Diameter. So diameter finding in meter is difficult. That won't be there. That you will get anyhow in decimal. So either you can use this itself or you can just convert in mm square. So after converting this, you will get 900 Newton per mm square. Now similarly, so here area will be what? In terms of d, so pi by 4 d square. So pi by 4 once you will find, you will get 0.7854 d square. And now in terms of mm square we are finding. So we have to find this d. W mean will be what? Already we have seen. So here W is given. So W mean is W max plus W mean by 2, which is W max is 500, W mean is 200. So 500 plus 200 by 2, that will give you 350 kilonewton. In terms of Newton if you want, right? Then you can write as 350 into 10 to the power 3 Newton. Now next, mean stress we have to find. Mean stress means what? Mean load by area. So mean load we found Wm by A. So mean load we have 350 into 10 to the power 3. Area is how much? 0.7854 by d square. So after this dividing, you will get 446 into 10 to the power 3 by d square. That is the value of mean stress, because in that formula, right, Goodman formula, we require sigma mean. So now we have sigma mean. Now variable forces like this amplitude one, that W max minus W mean by 2. So W max 500, W mean 200 by 2. After solving this, you will get 150 kilonewton, which is 150 into 10 to the power 3 Newton. Right? So variable stress will be what? Because variable weight we found. So variable stress WV by A. WV how much we got? 150 into 10 to the power 3 divided by 0.7854 d square. So now this you have what? Sigma V, variable stress. Now according to Goodman, again if you will see whatever the y projection is there, right? The same straight line. Again the same straight line is there. So what we have? Sigma V and sigma m. So sigma V by sigma E, in previous video also we had seen without factor of safety. Right, this time with that particular factor of safety is given. For endurance, how much factor of safety is there? For ultimate strength, how much factor of safety is there? So that's why whatever the factor of safety is there, just you have to divide by that term to this one. So factor of safety for ultimate stress is given as 3.5. So whatever ultimate stress is given, divide by 3.5. Whatever endurance is given for factor of safety for endurance is given, right? Divide with that. So endurance stress is given, divided by endurance factor of safety for endurance. So sigma v we got how much? Just now we found 191 into 10 to the power 3 by d square. Sigma is given as 700, and for that factor of safety is given by 4, right? So just substitute it, equals to 1 minus sigma m we found in previous one, right? How much? 446 into 10 to the power 3 by d square, right? So d square into the kf. This is what? Concentration factor, that is stress concentration factor. So now here this term will get multiplied with the mean value. So that is given in the question 1.65. So just see here that kf is 1.65. So now we have to put this one. Now what we will do? So this will go up, right? So now I'm just solving this one. So 190 of it. Now what we have? 191 into 10 to the power 3 divided by d square, and this I'm writing like simply, then it will be easier to understand, by 4, because with this we have to divide, which is equals to 1 minus 446 into 10 to the power 3 divided by d square divided by 900 divided by 3.5 for this one, and 1.65, right? So here we will multiply. So now this will come up. Similarly here also. So now this will give 191 into 10 to the power 3 into 4 divided by what? 700 d square, which is equals to 1 minus, now this will come here. So 6 into 1.65 already is there, into 3.5 divided by 900 d square. You can take this side, or you can just simplify, or you can further just see here, after solving this, multiply just d square, you can take common. Okay, so I'm writing here, right? So I'm taking this to this side. So 191 into 10 to the power 3 into 4 divided by 700 d square plus 446 into 1.65 into the 3.5 divided by 900 d square. This is equals to what? Now we can take d square common, because this both is there, right? So 1 by d square is equals to what? Simply whatever is there, 191 into 10 to the power 3 into 4 divided by, sorry, I'm taking just common, not this one, by 700 plus 446 into 1.65 into 3.5 divided by 900. This is equals to 1, right? So this you can take directly this side, d square to this side. So this will be d square equals to 1.91 into 10 to the power, or just 10 to the power 3 into 4 divided by 700 plus 446 into 1.65 into 3.5 by 900. So this will be your d square value. So after solving this, you will get how much? 1100, right? Right. Also just after simplifying, you will get, this is for 1100. So this will be 1100, and this will give you 2860, right? So after adding, what you will get? d square equals to 11. So what we got? D square equals to, from first term it was 1100, and from second it is 2860. So after adding, what you will get? This is 3960. So this will be a square root of 3960. So D will be equals to around 62.9, that is almost 63 mm. So diameter of the shaft will be 62.9 or 63 mm. So just see what is required. Determine the diameter of bar using safety factor to ultimate tensile strength and related to endurance limit and stress concentration factor. Means if this much diameter is there, then whatever the condition is given, that will satisfy. Less than that, failure will occur before the predicted or before the stress concentration factor, whatever is there. Before that, the bar or the whatever is there, that member will get fractured. Okay. So again, just see here. What we have to use? This one, right? From the starting, just summary. Area we have to find, right? That from area only we will get d square. 5 by 4, d square is the formula for area. We found W mean, right? W mean we got 350 into 10 to the power 3 Newton. Mean stress, W mean by A. That will give you 446, because A already we found, 446 into 10 to the power 3 by d square. Variable weight, Wv as W max minus W mean by 2. So with this, 150 kilonewton or 150 into 10 to the power 3. So now we have sigma m. We found Wv. So with this Wv we will find sigma v. Sigma v is W by Wv by A. Wv A given, right? After substituting, we got this one. Now from the Goodman formula, including the factor of safety and concentration factor. So here concentration factor of yield strength is given. So that's why factor of safety for yield and factor of safety for ultimate. These two is given. This is 4 and this is 3.5 given. And factor of safety is given as how much? 1.65. Now substitute all the values, right? And simplify. Then you will get d square as 3960. Take the square root of that one. You will get the answer 62.9 or you can say 63 mm. Right? So now by using concentration factor, we found the diameter of the bin. Now that circular cross section, that member is given. Right? Okay. So now we will see next class another numerical. Okay. So related to this numerical, if you have any doubt, you can just mention in the comment or you can just ask me directly. Okay. Yeah. One more thing. For this question, if you have any doubt, you can refer this also. There you will get the question and solution of that one. Right. So actually from this website directly you will get, but that website itself is taken from this one. So that's why I mentioned here, so that easily you can find from this website. So with this reference, you can see that question you will get. Right. And still if you have the problem, you can just link saying that contact me or just comment on the videos. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.